So, what can I measure with this? Yes? Distance? What do you mean? Okay, what can I measure of this? Not what I'm going to do with it. Alright? What can I measure?
Nothing.
The wingspan.
No wings.
Okay, I can measure this. Yes?
How quickly it goes to the ground.
Okay, the question is, what can I just measure of this? Not what I'm doing to it. With it. Huh?
Okay.
The weight.
Wait.
Alright, but we like to say
Mass.
mass. Okay. Now. Okay, so I'm gonna need your help, so ooh.
Sick. Ooh.
Whoa.
I warned you. That was, I don't know, I probably wouldn't want to redo that one, but I'm not going to. Alright, so let's see if I can make it back here. Alright, so. Alright, so, yeah. Now what can I have measured? Yes?
The successful attempts and how long it
What constitutes successful?
the height of
Okay.
how long it fell.
The height at which it started. Okay. Again, the mass. What else?
How long it took for it
The time it took for it to go down. Now, I could do this, click, click, or which would be very accurate time, or I could be like, what do you think for right? You know, someone will always say the number of rotations. That's probably harder to do. But so we have something, right? Yes, no, maybe. Those are all. Now I can make a prediction if I do something else. What am I doing now? I'm increasing the mass. And then I can have, we're going to learn about this, I can have 1 paperclip, 2 paperclip, 3. We call those levels of independent variable. Okay? So, let's do this. Let's write down a couple terms here. So, independent variable, that is what? You have the notes here, but what I want to do with this is give you some buzzwords to go with this. So, purposefully change. All right, let's add in that it's a intentional change. And forgive my terrible handwriting. It's an intentional change. And there's actually another word we're going to use in a second, but let's talk about DV now. All right. So, and Mr. Dean likes to always point out what I change. All right, that's a way to remember it. Of course, when you're writing your official paper, you're not going to say I did this. You would say the increase or decrease. You're describing the manipulated change. Okay, so the dependent variable responds. Let's underline this, and then hey, see this? That's another way of saying IV. That make sense? The manipulated change, the intentional change, the thing I set up. Of course, setup is broad because you actually set up the whole experiment. Okay, so it's a manipulated change. Now let's look at the notes. It's usually measured. So now, right when it's talking about this, usually measured with stopwatches, measuring devices, balances. That's not part of the definition of dependent variable. That's just talking about how you would actually get your results. All right. Now, so let's talk about constant and control. Actually, let's do control first. Okay, then we'll finish with constant. Okay. Alright, the standard of comparison, that's true, but the definition of control really isn't on these notes. So let's add it. And think about it like this. If we're going to do the helicopter experiment, you've already seen it. You've already seen the control. You've already seen the control. I dropped this, didn't I? Does the control have data and results that can be put in a like a data table or even graph? Did I do that 3 times? Okay. Have you seen the IV?
Yeah.
No. You've only seen the control. So now this is the IV, right? Here's the simplest way to remember this for me, and hopefully for you. It's doing the experiment. I'm just going to write EXP for experiment without W/O without the IV. Why don't you guys write the full word? I'm going to use just a moment to say throughout the year, I'm going to sometimes abbreviate stuff, but you should make it make sense for you in your notes. So write out the word without until you're used to my lingo. So doing it without the IV. Does that make sense? It should have data. It should be done that you set up the experiment and you run it and you record your results and then you make your intentional change and you run it. Or you do them at the same time. I can have 2 different helicopters. Okay. Now, before we make our prediction, which is what the hypothesis is, let's talk about constant now. All the factors remain the same and has fixed values in the experiment. Now, what is the most important constant for this experiment? Or what is the constant? Yeah. The height at which it was dropped. Because if I did this experiment, where I did it like this, dropped it, and then I did it like this and dropped it, and I did that, and I said, well, that one went faster. That's bad science. All right? If we're gonna increase the mass, we should do the same length starting point every single time. If I want to do different heights, then I use the same mass. See, the thing about that is the constant, the most important constant, is the one that could become a variable. Does that make sense? Now, what students want to do is they want to list equipment. They'll give you like 15 different constants. There's always probably 1 or 2 that are very important. The one that could become a variable. Does that make sense? And when we start looking at these word problems, you'll see that. All right. So we've made our intentional change. Right? We've made our intentional change. Now what we need to do is test the experiment and come up with a prediction. An educated guess, I said that's not good enough. You have to say something else. So it's basically, instead of saying educated guess, I'm going to write in here a prediction. Now, if I want to be grammatically correct, I should say a prediction about the relationship between variables. All right? The relationship between variables, meaning the IV on the DV. Now, don't mess up your notes. If that doesn't make sense, what I don't want you to do is go home and look at this and say, what in the world do we do in class? Some of this is I'm talking about, and I want you to make more notes in your notes. Your notes are your notes. Remember that. Are there any questions? Okay, we'll talk more about repeat trials, but the gist of it is every time there's a measurement, or if you have like 8 people doing the same experiment, each one of those is actually a trial. So it's not like each person has to do it. Now, you saw me do it 3 times. That's good. So are we ready to make a prediction about our... Give me a hypothesis based on increasing the mass of the helicopter as it relates to the speed. The increased mass is the IV. The speed is what?
Faster.
The speed is
Decrease.
the DV. Now, when you said faster, you were making a prediction.
Ooh.
Okay? But I asked what the DV was. And that's the subtle thing between getting something right or wrong on a test. You know it, but don't jump ahead. All right, I'm only pointing that out because that's how students get something wrong on a test. You just want to yell out faster. But the question was, what's the DB? You gave me a prediction. The speed. Good.
Got that on for
Hold this. Okay, so our prediction was what? She's really enjoying being the assistant today. So, give me a prediction.
As you.
Oh,
It's gonna go faster.
Yes.
if the mass of the object is increased.
Stop. This is a very specific example. Why did you say object? We know what this is.
I know.
Okay, so start again.
If the mass of the helicopter is increased, then the speed will increase as well.
Okay. All right. So, try one. Now, I don't have results for that because I'm just saying, but we'll go by a qualitative visual. All right. All right. So, try one. Two. Go 3. All right. So now, what do? A conclusion. What's our conclusion? All right. Someone else. You gave us a good hypothesis. What's the conclusion? Remember, in science, sometimes someone makes a hypothesis, but someone else actually tests it. Give me a conclusion. Okay, the conclusion is based on the hypothesis. The hypothesis was that the increased mass will go faster. Did it go faster? Okay, yes. A yes-no statement about the hypothesis is really what we want our conclusion to be. All right, so, are there any questions? I have my, so what we're going to do is we're going to shift now and I'm going to stop this for a second and we're going to fill out this now.